So this is pick any three good, fast, and safe DevOps from scratch. We're going to be talking about some of the specific things that that threat stack where I work at has optimized for really early in our growth, and just kind of share a story of what we've been doing over the last many years and what we continue to invest in today. So before I get too far, my name is Pete Cheslock. You can find me on Twitter at Pete Cheslock. I used to tweet a lot more, not so much in recent years. I mostly just tweet about like smoked meats and things like that. If you like smoked meats, maybe you should follow Pete's Meat Tweets every weekend. So. I do technical operations for ThreatStack. I've been there for almost 4 years now, and we have grown substantially over that time. And when we started, we were essentially had this greenfield environment. So what I think you'll find as I kind of share this story and this progress of what we've done is how we've kind of made important optimizations very early that I haven't really seen in previous companies. So you've probably heard something like this before, right? You can have only two, pick any two, good and fast, safe, things like that. Because obviously it's not possible to have all three, you just can't. Or at least that's obviously what we're led to believe. That in order to move fast, that you maybe have to undertake risky behavior in your environment, or to build something secure, you have to go slowly. I just don't think that's the case anymore. So if you know anything, if there's one thing to know about me, is that there's always a unicorn slide. This is a new unicorn slide. But what I'm here to tell you is that I think you can pick them all. I think you can build stable, scalable systems that are good to work with, that are safe and secure, and you can do this in a fast way. You don't have to give up the continuous integration, continuous deployment that we've all become accustomed to. And so that's kind of what I'm going to focus on. And I think that's right where the unicorn lives, right in the middle. So who here has heard of ThreatStack before? I like it. Who here's a ThreatStack customer? Anyone? A few of them? Awesome. That's great. So for those of you that have not heard of ThreatStack before, what we do is we run a cloud security operations simplified. So basically what we're trying to do is help give visibility to our customers, understanding who did what when in their environment, making it easy for them to kind of build trust with their customers internally and just secure their future growth. And so what our platform really helps is a lot of customers who are trying to go through a PCI or a SOC 2 or HIPAA compliance, and it really helps them kind of meet those compliance needs. If you want to chat more about it, I'm here all week, and I'd love to chat just how people are doing things in their environment and trying to bring security into this new model of cloud and things like that. So one thing I don't think Jason asked is how many people are here for their very first DevOps Days? This is the first DevOps Days. Awesome. Wow, this is amazing. So we've got some kind of noted thought leaders in the audience. So this is, I'm looking at you, buddy. So I like to level set, right? I want to make sure kind of we're all on the same page. So for some people, this is going to be a refresher, but that's all right. So I want to start off with just like, what even is this DevOps thing, right? Because it could be a lot of stuff. Is it a tool that you can use? Maybe a service that some consultant might implement for your company? Maybe it's even a software that you can buy. But hopefully that software is concurrent DevOps. Don't come into my house with any of that single-threaded DevOps nonsense. Please. You've got 16 cores on that DevOps, and you're only using one of them. You don't need a bigger one. So is it a job title, though? How many people here are DevOps engineers? It's all right. No, it's no problem. I used to be a director of DevOps, so you can't have a worse title than that. But it's fine, because it's now become this qualifier, right? But is it a team? How many people are on their DevOps team? I won't make you raise your hand, but do you also have an ops team, too? We'll talk about that. But I understand, and I get it. DevOps became this qualifier. That was, I need a system administrator who can code and work with cloud services. So how do you find a system administrator who can do all that? Well, to be honest, back in the early aughts, or as I like to call it, the last bubble, people did that. We wrote code to manage systems. We didn't have all the kind of great automation tools that we have today and the great cloud services, but we still wrote code. I mean, it was a lot of Bash and Perl and other terrible things, but it was still code. So what is the DevOps, given all of that? It's anything your heart desires, right? It can be anything you want it to be. It's just a word. How many people here have been to Zombo.com? Because I think DevOps is like Zombo.com. And for those people who have never been to this site, you're welcome. This is a website from like 1999, and it was making fun of Flash websites that just had endless loading and music and stuff. And I think DevOps is like Zombo.com because it promises the world. And in the end, you just get some animation and some kitschy music. But when you go to the site, turn your volume up, trust me, and you'll hear this just wonderful voice and this music. It's just like, you can do anything at Zombocom. Welcome to Zombocom. And it's just great. So it's also probably pretty stupid, but it's just someone converted this over to HTML5 as well, so it's not lost to the world because it was a Flash site, so like doesn't work anymore. So again, just bookmark it, save it for later. If there's one thing that you learn from this talk, Zombo.com. Anyway, let's talk about the bad old days. How many people have been in the industry for, let's say, greater than 10 years? Show of hands. They'll keep your hand up if you've been in for greater than 15 years. And then greater than 20 years? So good amount of people. Okay. So the good news is I'm sure there are people in this room that have walked into a physical data center before, right? And had to rack and stack servers, and it's terrible. That's the bad old days. But that's not what I'm going to talk about. This isn't even that old. By the way, this is my favorite tweet. Taking Twitter down for a little nap. The site and message delivery will be back within 4 hours. If you look at the date, it's 2007, which doesn't seem like that long ago, but it really was a world ago. I do think this is hilarious, too, because it's like taking it down for a little nap. Like, what does that even mean? But what's amazing about this, can you imagine this happening today? Twitter just being like, we're just going to go down for 4 hours. It's cool. Now, granted, in a lot of ways, that would be really nice, but OK. So Twitter isn't the only company this happens to. I was trying to get my flight details to come here to this event. I'm in the Boston area. And I got the little sad face from JetBlue. It's like, we're just undergoing some scheduled maintenance, right? So maybe the bad old days weren't really that old. This is still happening today. So let's talk about the bad old days of software. So in the bad old days of software, you had devs who would rarely have access to production systems. And it means the ops team would have to take the code and install it kind of based on their instructions, right? So when the devs delivered this code to an ops team, what kind of testing took place on that code? How many changes were comprised in that code diff there? How many days, weeks, or even months of changes were in there? So what about when we had kind of legitimate packaged software, where we had to burn software to a CD and then get it to production and get it shipped out, or God forbid floppies if you're that old. So like, how do you get changes out then, right? It's like service pack 1, service pack 2. You still get changes out. It's painful though. So let's talk about the bad old days of infrastructure. The lead time for new servers could be measured in maybe best case scenario weeks, or months in the worst case scenario, or maybe even a year. I mean, it could be a long time. You got to go through procurement. You got to spend millions of dollars on these things. You got to rack them. You got to stack them. You need power. It's a huge pain. And systems at this time, these were lovingly hand-built, bespoke, artisanal servers, right? System administrators were so proud of their uptimes. How many people here were really proud of their system's uptimes, right? You had that one server with like a 9-year uptime. Yeah, just the poor sap that has to reboot that thing. Is it going to come up? You have no idea. It hasn't been restarted in 9 years. But I work for a security company. What do you think I'm thinking about? When's the last patch that server had? How old of software is it running on there, right? So now you have this huge security vulnerability as well just sitting there. But you type uptime and it's like 9 years. It's like, woohoo. So if you buy servers too, anyone here understanding kind of like CapEx and OpEx is a term you hear a lot. Capital expenditures, you buy servers, you depreciate them over years. So if you were to buy like millions of dollars of servers and you can't actually get them to production, let's say it takes you a year to get these servers into production, you're just lighting money afire and they're of no value whatsoever. And so being able to get these servers into kind of production as fast as possible is huge, and it's a huge cost to the business if you don't. So back in kind of the late aughts, there have been a lot of really great conference talks about DevOps, and terms like agile infrastructure were being talked about. There was a great talk at an Agile conference actually called Agile Infrastructure by Andrew Schaefer, which is still online, and I really recommend watching it. But in my opinion, personally, the talk that really blew my mind was this Velocity 2009 conference talk. It's also still online, and I recommend watching it, by John Allspaw and Paul Hammond. John Allspaw went on to be the CTO of Etsy, and Paul Hammond went on to go and do Slack. They were at Flickr at the time, which was a photo sharing site, if anyone remembers. They were bought by Yahoo, and they're still around. But these two guys came on stage, and they were saying how we're doing this dev and ops cooperation inside of Flickr, and how they were doing 10 deploys a day, right? It was mind-blowing. 10? No, you're lying to me, right? I can't even do 10 deploys a year, and here they're saying they do it every single day, right? So from their talk, there was this traditional thinking that it was the dev's job to add new features. sounds sane. And it's the ops job to keep the site stable and fast, right? And then you had this classic like wall of confusion. How many people have seen this slide before? It's a very common slide in kind of the DevOps whatever world. You've got these conflicting incentives. You've got on one side developers who want change, and they're being driven by product and other things to get change out. And on the other side, you've got operations, right? They want stability. They don't want to get paged in the middle of the night. So you have these incentives. They're not aligned. And what happens is maybe there's some miscommunication, right? Like so close. I want to know the backstory of this picture. I really do. I found it online. It's amazing. So, okay, we're in the future now, and you're doing the DevOps. You're doing the DevOps in every way possible, right? And you've got these happy dev teams and these happy ops teams. Did you even include your security teams as you were bringing out all these new whiz-bang fun technologies like configuration management and continuous delivery, things like that? Or did you just leave them on the other side of that wall? Or did they just not want to get involved? I've seen that as well. They're just like, we're just going to be over here and do our thing. So now you're back to the same problem we had before, which is the incentives are not aligned anymore. You have a team now going incredibly fast, and the security team is just being completely left behind, right? So what does that turn into? That misalignment manifests as maybe like a half-baked security solution, right? So this is checkbox security right here. It's like I went and bought a thing that checks a box, and I show it to my auditors. Look, auditors, I have access control, right? So from that velocity talk, it's not the operations job to keep the site stable and fast. It's both the ops and the dev team's job to enable the business. And you often hear about like, well, don't forget about marketing, don't forget about sales, and that's true, right? It is really, truly the whole business, right, enables the business. Everyone's working towards that one same goal. So how do we do that when we're talking about ops and dev teams, right? They do that by lowering the risk of change through tools and culture. And the important point here is you need to do both, right? You can't just bring in some new tool. If your culture is completely broken, bringing in Kubernetes, you're just going to have a really bad time. But if you're bringing in, you have this like really awesome culture, but you're using all of these legacy tools, you're going to have similar pain, right? So this is the story I want to share with you. So that's kind of level setting off. The story I want to share with you is basically in 3 acts, where act 1 is we optimized for deploying software, making it very easy to get and deliver software to our customers. Where act 2 is how metrics are a first-class citizen and what we did around there. And the last thing is ownership and accountability, which is, I think, the most important part of all of this. You can't even have ownership and accountability unless you even do the first ones. But each one builds off the last. And I think this is a lot of where we made these decisions, and they kind of got us where we are today. So software deployment. So in today's age, modern operations is basically how do you install X on Y? Almost everything we do in operations in a lot of ways is how do I install this thing on that thing? Maybe it's how do I put Kubernetes on AWS or Cassandra on Azure. Maybe you're just building some Debian packages and you're deploying them. Maybe you're building Docker containers, deploying those. But one of the very first things that we did at ThreatStack was make it incredibly simple for any developer to just push button, click, get their code into production as easy as possible. So how that looked 3+ years ago to now is not that dissimilar. It's mostly the same thing. We've abstracted away all of the complexity of kind of packaging and deploying software away from our engineers, and we basically tie it into our CI and CD systems. Originally, we used Jenkins for this. The more you use Jenkins, usually the more you're going to hate Jenkins, unless you really love Jenkins. Sorry, CloudBees folks. So, but we... Yikes. So we ended up moving over to GitLab actually more recently. That was kind of killing 2 birds with 1 stone there. We were able to bring our source control in-house. We were able to bring CI and CD in-house and kind of manage it all from there. And again, as a security company, we have different requirements than other companies, but it's been really great for us by having that become that kind of single place that anyone can go to do a thing. So what does that actually look like? Very simple deployment pipeline where we will compile your source, we'll build a package, we sign the package, we then test that package, and we deploy the package. And one thing I usually like to point out here is this part here is kind of important, signing the package. Now, if you're deploying like say RPM files, you actually sign those. If you're doing Debian, you're kind of signing the repo, and it's a little ugly and gross. If you're doing Docker, I don't know what you do with that. Sorry. But the key thing is that signing the packages and abstracting away the complexity of signing packages makes it very easy to ensure that the bits that you are testing are the same bits that you're deploying to production, and that's important too. Depending on how your software is built, is it possible that an engineer could just kind of slide in a quick hot patch, somewhere between testing and deploying to production? Is that possible? I don't know. It totally depends on your deployment strategy. But if you sign that package or take a hash of it and save that hash somewhere when you deploy it, you can at least have certainty that the code that goes to production is what you tested, right? So at ThreatStack, we basically follow this process. But more importantly, when that deploy action happens, we deploy software when it's ready to go. So what does ready mean for us? How many people have been through a SOC 2 process? Okay. If you want a hug after, I'm available. I know how painful they are. So ThreatStack, we went through our SOC 2 process last year. In a lot of ways, it was great, and I could fill 30 minutes just talking about that. So if you do want to talk about SOC 2, happy to. What's that? Open spaces. Yeah, we'll have a SOC 2 open space. Or just, we'll all hug and cry together. So if you haven't been through a SOC 2, don't freak out. Like, it's really not that bad. But what was cool about the SOC 2 process for us is that it allowed us to define the processes of how we do things, how we deploy software. So for us, what does ready mean? It means it's been reviewed by other engineers, it's passed a series of unit integration and functional testing, and it's been reviewed to ensure it meets other business or security requirements. Now, this is language directly that we give to our auditors, and you can notice it's maybe a little vague in some places, but it does comprise everything we want. So we have a SOC 2 that we need to abide by, and that means we have these business requirements that define kind of the states that tickets have to be inside, whether they're in test, whether they've been approved, et cetera. But one thing we learned initially was kind of hilarious in that some of the engineers were like, I'm going to break SOC 2, and we're going to fail the audit, and it's going to be so terrible. And so there was a lot of weird anxiety around, I got to create either 1 million tickets to make sure I don't miss a thing, or I got to create and kind of freak out that the ticket's in the right state. And so the biggest issue we ran into came to that process, which was when I am deploying code, how do I know that that code, all the code, may be deployed by some other people that I don't talk to on a daily basis, is ready? So we created a tool called Sock'emBot. Sock'emBot, if you remember those little Sock'emBot robots. So Sock'emBot basically ties into our GitLab instance. So when you create a pull request, or in GitLab it's called a merge request, Sock'emBot will run, and it checks your code in all of those changes, in the entire code diff, every ticket that's in there. Because maybe some of that code is my code, some of it's another engineer's, maybe that engineer's on vacation, who knows. But it will check all the code, config management code, application code, doesn't matter. And it makes sure that all the tickets that are referenced are in that correct state, where that correct state is what our SOC 2 has defined. And you can see right here as an example, this is just, we're pushing some chef stuff, and there's some tickets, they're approved. What's great about this process and this tool is that it basically tells the person doing the deployment that that code is ready to go, and there is no risk of breaking SOC 2. It's been through the proper approval processes. But if for whatever reason those tickets are not in the correct state, then Clippy is going to pop in and let you know, right? How many people here don't know of Clippy? That's good. Okay, so Clippy, obviously the helpful assistant from Microsoft Office. It's become a bit of a meme inside of ThreatStack. Whenever we deprecate something, we usually put a little ASCII Clippy of like, please stop using this thing that we deprecated. So of course we had to put it in here. And it's annoying because it's like, did you mean to follow SOC 2? Well, yeah, yes, Clippy, I actually did mean to. So, but it tells me here that there are a couple of tickets that are still in progress. And so what I can do then is go and check the status. I can go ask those engineers if they are ready to go, get them approved, and then deploy the software. But every project is different, and we basically they might have other reasons, other applications might have different states for what ready means to them. And so, we might say different things to those engineers. Can you say that you're doing SOC 2 if you don't have at least one Mean Girls reference in it, right? You go, Glenn Coco. You should watch Mean Girls. It's a good movie, sorry. So let's talk about metrics. What ThreatStack did from the very beginning was make it extremely easy for any engineer to get metrics where it's got to go. We standardized how an engineer could get metrics by using some simple tools on our systems like collectd and statsd that allowed engineers to have a single endpoint that they could push metrics to. But in the initial stage, we had no time to build our own monitoring. We used hosted services like Librado, and they were incredibly successful for us. So on the ops side, it was our responsibility to kind of build and make these tools easy to use, but it's the dev's responsibility to instrument their applications, to understand performance, right? So in the initial setup, we used, like I said, collectd. You'd have a bunch of different apps. They'd write to the statsd plugin in collectd. And originally, before we used Graphite internally, we were sending these metrics to Librato. The endpoints were all the exact same. When we made that change later, no engineer had to actually change their telemetry in their code or any of their monitoring, because all we did is we just kind of swapped the backend from Librato to Graphite. And of course, there's tons of training we did about how like Grafana works and how to interface with there. But it was incredibly helpful at this time that it wasn't like moving from one completely different thing to some completely new thing, and now everyone has to rewrite everything they've already done. So it's dev and ops, though. We work together to ensure we're using the right instance types for the workloads. So ThreatStack we run on Amazon Web Services, which is great. I love it. I never really want to use another cloud. The great thing about Amazon is if you want a server, you can get it. And you can just spend all your money all day, right? And the bad thing about Amazon is that they will just take your money all day. And so you could just let your developers run like whatever instance they want to, right? You can figure out how many X1Es you can spin up in your environment at $25 an hour for that one. But a lot of times they're just not thinking of like the cost implications, and there's a lot of nuances to figuring out how your spend on Amazon is going. So I know a lot of people are like, no, I'm going to solve this because what I'm going to do is I'm going to just run Kubernetes, right? And the devs will write and they'll say, hey, this is how many CPU and how much RAM I need, and they'll totally pick those numbers correctly, and they won't overextend their promises there at all, right? And just Kubernetes will deal with it. So if you're one of those people thinking of that, I've got some very bad news for you. Turns out engineers and even operations people are all really bad at figuring out the right resources for their applications. Obviously, most people want the resources to be high. You don't want to get paged because you're being too cheap. But at the same time, you have to work together. And metrics are a big part of this. So how do we know that this is actually working? Our engineers go and build the dashboards. They spend this time as part of all of the testing and deployment processes to build these great detailed dashboards that give insight into their applications. Anyone can open these dashboards and get an idea of what's going on. And the engineers are really incentivized to do this because if there's an outage or someone gets paged and the runbooks aren't up to date and the monitoring is not up to date, then this engineer is going to likely get woken up, right? So it only makes their job easier to build out these dashboards. And again, what you're missing on this part is that we didn't just say, hey, here's Grafana, like go nuts. We actually did a ton of training sessions to teach people how to use this. And what happened after the fact is they took it from here and started building out dashboards that I would never have thought of building. So the last part, though, is ownership and accountability. So operations owns the infrastructure, and that's kind of a broad term. I've heard of some places say, well, everyone kind of owns the infrastructure, which is usually kind of code for no one owns it. But I usually say that we own the overall kind of health of the infrastructure by building tools that enable teams to use that infrastructure appropriately. So we build a lot of tools that let and make it easy for engineers to deploy their code to Amazon or to whatever they're trying to do, or to provision servers, or I need this instance type or that instance type. We try to abstract that stuff away and make it extremely easy for them to do that. We know that engineers build better code when they're responsible for it, and that's one of the bigger parts of this ownership and accountability, is by giving those engineers that ability to make those changes and deploy their code whenever it's ready to go. And as you saw as part of our SOC 2 process before, they deploy the code when their code is ready. And as long as it meets those requirements, then they can ship it, right? And the same thing, they're incentivized to create these great dashboards and these great runbooks because if they don't, they're just going to get paged as part of it. And at the end of the day, everyone cares about the health of ThreatStack. Not just ops and not just dev. We all care about it. We care about the performance implications if things are not working well. We want to know about it. So how do we do DevOps, right? Kind of the broad, how do we do DevOps? The ops needs to trust that devs are going to involve them on feature discussions. There is nothing worse if you've been in this position where your devs come to you and be like, hey, we just built this new awesome thing. Like, we just need a Kafka server. Can you just like roll one of those up, or like a whole Kafka cluster? It's like, well, we don't have Zookeeper. We don't have Kafka. We never used this before. Like, what? So you have to have those lines of communication be very open. And on the reverse side, devs have to trust that the operations teams are going to discuss infrastructure changes. And this is a perfect example of I've seen places where they deploy software in a certain way and someone's like, no, you're doing it wrong. You need to use Docker. And they start pushing everything into Docker without understanding the implications of that. And now all your devs are upset with you, which is not usually where you want to be. Everyone, though, has to trust that everyone else is doing their best for the business, though. And this is kind of a broad statement across the dev and the ops and product and sales and really everything. So I work for a security company, so we got to talk about DevOpsSec, right? Wait, no, hold on. Sec DevOps? Or is it Ops DevSec? Or DevSecOps? Ops? I might have duplicated one. I don't even know. So whenever I hear these terms, I just think I'm like reading a Dr. Seuss book, right? And also, too, the places you'll go. Just add the word security into your DevOps and, everything will magically happen, right? I often think, and I have to remind my marketing team very often to not use the term DevSecOps because it has no meaning, much like DevOps. But what if we just incorporated security into DevOps and we just called it DevOps, right? What if it was still DevOps? I don't know. So my biggest thing, though, is it's been about 10 years now that I think this DevOps idea has been mainstream. And I don't think that we can still agree on what DevOps is. We only know it when we see it. So I don't think we're going to come to an agreeable definition on what DevSecOps is going to be either. And at the end of the day, integrating in your security teams with the rest of the business, this is hard work. So at ThreatStack, our security engineers, they actually do more ops work than I would say most ops teams do. And I actually say that similarly to our dev teams. They do a lot of ops work because they're managing the systems. You build it, you run it, and that's the mode that we follow. So does that kind of mean that we're doing DevSecOps? Maybe. I would say the lines blur between our security infrastructure engineers and our infrastructure engineers, our kind of operational ones. But I do look at kind of our SecOps program that we created within ThreatStack and how impactful it was for helping us pass our SOC 2 just recently. And a lot of that comes to tools that were built to make it easy, to reduce the anxiety that people might have, and basically having a really good user experience when it comes to security. There's a lot of security tools out there that are just terrible. So having a good experience is the best way to have people really start using those tools. So how do you actually do this, right? How do you actually integrate your security teams? And I think in a lot of ways, it's similar to how we integrated developers and operators years ago, or just now if you're just getting started in this. We align the incentives and we try to share tools that will enable both groups to succeed. So examples on this one would be something as similar as hey, what if your security engineers use the same CI and CD systems to do static code analysis on your code, or to check for vulnerable software in your dependencies? Or what if you teach them how to use Puppet or Chef to deploy some new security stuff they want to do? If they want to deploy some new tool out to production, some new security tool, what if you show them how they can do that? One of the things that we do, which I really like, is we actually tie in ThreatStack into, because again, we use ThreatStack to protect ThreatStack, which is cool in itself. But we have these things filter into our same kind of chat systems, and we make security really visible. And we integrate this alerting into the same workflows the company is using, like Slack. And so that way, if there's an event that happens and we get an alert for it, like I was rolling some new graphite systems and we use DNS for things to find things, I can just pop in there and be like, yeah, that was me. I was just doing that. Nothing wrong there. And this was a few years ago when we had this level of integration. What our future looks like is kind of a scenario where an alert goes out and you just send a DM to that person and say, hey, we just saw this alert. Was this you? And you just say, yep, that was me. And Slack has all these great APIs that tie into that. Or really any chat system you can tie in and do this with bots. There's a lot of great ways to do that. This is one of my favorite quotes. It's kind of more specific to security, but honestly, I think it really applies to everything, which is abrasive individuals will single-handedly do more to undermine the security brand and culture at your company than anything else. And I think this is true for really all parts of the business. But the biggest thing, if we are talking about security, if you don't have an approachable security team, it's not that the bad things won't happen. It's that no one's going to talk about them when they do. They'll just keep them to themselves, which is arguably much, much worse. At ThreatStack, our security team actually holds open office hours once a week. People can just come in and ask questions about anything, right? We follow a whole kind of incident response plan where if you have an issue at any time, you lost your wallet with your badge or you lost your laptop, you can send a message to a group of people on the security team, and we'll help you out, right? Clicked a link in an email accidentally, don't know what you did. And there's no blame. We don't go around and be like, how dare you, did you do that thing? We try to keep it open because accidents happen, and it's hard. Security is hard, and you have to keep the lines of communication open, otherwise it all breaks down. But the best security cultures are collaborative. They're not prescriptive. The easiest way for your security team to lose trust within the business is to just basically say, at a blanket level, no more doing X, Y, or Z, right? Everyone's going to immediately hate that, and then they're immediately going to go and do the thing anyway, right? And that's kind of where we ended up in this state. For a long time, security teams were slowing down the development processes, and the rest of the teams were like, well, we've got to keep moving. So what do? They grabbed the closest credit card, and they went to Amazon, and they got whatever servers they wanted to and deployed their apps. And now the security team is like, what is even going on? We have all these servers out here. No one knows what's up. So you have to, again, work collaboratively to solve problems versus just being that department of no. That's really the key to the whole thing. So if you want to improve how your business gets work done, how your technology moves forward, you just have to realize, though, this is hard work over a long period of time. So I started from basically a greenfield environment 4 years ago, and it still took us about 4 years to get to where we're at today. And I think there's still so much more we can do. So if you're starting a DevOps transformation, just know that it's not a matter of getting to the finish line. I don't think there's a finish line to a transformation like this. It's just this continual process. You're continually moving the ball down the field, making every day a little bit better tomorrow than it is today. Thank you very much.